Hello friends, today I'm going to solve LeetCode problem number 1519, number of nodes in a subtree with the same label. So we are given a tree which is undirected graph, and it has a number of nodes numbered from 0 to n-1 and has exactly n-1 edges. And the root of the tree starts from 0, and each node is also labeled with a lowercase character, and the character is given in this string, right? So the character at label I is the character at index I of the labels string is the label of node I. Now we are given the edges, we are given the labels. What we need to find is we need to find the count of the label of that node in this whole subtree. So how many times does this label repeated in this whole subtree? Well, basically for this node it is repeated twice, right? Because the subtree it represents is all of these tree, so it is repeated only twice. What about B? Well, the subtree that it forms is only this much, and then B is not repeated more than once, it's only occurring once, right? So for this the count is equals to 1, so that is what will return at index 0. Will return the value 2 for the count of its label in this subtree, and at index 1 we will return the value 1 as shown here, because we only have one count for B. And similarly for index 6 and index 4 we are also going to return only value 1, because even though this whole tree has two nodes which have the label D, however this subtree, this node which forms its own subtree doesn't have any, only has one D, right? So that is the reason why we only return 1. Now let's see how we could solve this problem. So I have copied the problem here, and now what are we going to do is we are of course going to start with the DFS function. So before that, since we are given these values, so what do is we are not given a tree, we are given these values. So from these values we construct the tree. So for that we need to build an adjacency matrix. So we build an adjacency matrix. If you don't know how to build an adjacency matrix, you could just look at my previous videos, because I have explained there how to create the adjacency matrix, because this problem is quite similar. Now once we have created the adjacency matrix, what we do is now we start from the root node, that is index 0, and then we perform our DFS function. So we are always performing DFS on this tree. So what we do is we move first to its left subtree, and then again from this tree we go to the left subtree. And now we try to go to the left, but we do not have any left subtree, nor do we have any right subtree for this tree, right? So now since we have reached the I mean we cannot move any further, so what do is now we compute the number of the count for the label at this index and any other that we might have encountered. So here, since we have only one label for this whole subtree, the label that we have encountered is only D, and the value is equals to 1, right? So we create this label, and then what we do is we return back with this value. So we are returning this value here as well. So the value now is equals to D equals to 1. What we do from here is now we also go to the right subtree, and then similarly we create a map and then the count of the label. Since we only have one label for this subtree, so we only create that one and then we return it. Now for this subtree, what do we have? It consists of these and this as well, right? So while we are returning, we return this value, and then this value is added appended to this, the map that we create for this one, and then we also take the value for this label, that is b equals to 1. So we have created the count of all the labels in this subtree. Now we return this value to our 0 index. So we have all of these values, and for this index we go to its right and then to its left, because we are performing a DFS. So we go to the depth first, and then here the label is equals to e, so the count is equals to 1. So we found our map dictionary, and then we return it back to a, and then the value here becomes equals to e equals to 1. Similarly, we return the value of d, which is equals to 1 for this case. And then while we are returning, we also need to update our resulting array. So we'll store our final result in this array, which is of size n. Since we have 7 nodes, so 0 1 2 3 4 5 6. All right, so we created boxes for each of these. Right, so while we were visiting, before we return to its parent, we are going to update the index, the value for this label as well. So since the d only has one count, right? So for index 4 we return the value 1. For index 5, similarly, c only has a count of 1, so we return the 1. Here, when we reached here, the value for b is 1, so we returned a 1 for index 1. And then we came back here, but we moved back to its depth, and then for index e, the label is equals to e, which has the count equals to 1, right? So at index 3 we return the value 1. Similarly, for the index 6d, we return the value 1 for the label d. And then now at index 2, we have these two values from its children, e equals to 1, d equals to 1, and then a for itself. So a is also equals to 1. So we return all of these values to its parent node. So what does this parent node have now? This parent node have this value from its left child, and this value from its right child. And when it combines both of the values, what is the final value? D equals 1, c equals 1, b equals 1, a equals value 1, e equals to 1, and then d equals to 1. But we also need to keep in mind this value, right? Because the whole subtree comprises of this node as well, right? So since we have the label a, and we already have the label a here, right? So what we are going to do is we are just going to add a +1 to this value. So now the value at label a is equals to 2, and index 0 has the label a, right? And the value of label a is equals to 2. So what we do is at index 0 we return the value 2. So this becomes our final result. Now let's try to code our answer. So first of all, since the labels given is a string, so we are going to convert that to an array. So okay, we are not going to define. And now we create our adjacency matrix of length n. And since each of the element in the adjacency matrix is also a matrix itself, so what I'm gonna do is we also need to define each of them as a matrix, I mean an array. because each of the element is an array itself, right? So once we have this, now what do is we create our adjacency, we fill our adjacency matrix. So now once we have created it, now let me create our DFS function. We pass our node and our parent, and then we define a map variable to store the count of the labels we have encountered in that subtree. And then what do is we loop over each of the neighbor of the node, and we also keep check if the neighbor is equals to the parent, because we do not want to go back. So we just continue if the neighbor is the parent itself. If not, what do is we perform our DFS function. So let's store our value from the DFS call into our val variable, and then perform the DFS call. And also before that, let us define our result array of length n, and okay, so what are we going to return here is a map. We are going to return a map, right? Okay, so we return a map from this one, and this map value, what do is now we get the value of the map of its child. Now we combine that value from its child to the value of the map of the node itself. So what do is let the label and count of from its child. What do is if our map has this value, then we are going to use it, else what do we create our label okay, BEL, we set it to 0, and then I'm just going to copy this value, and then we increment the value by the count of the label. And then what we need to do is we also need to add to our map the label, the count of the label of that node itself, right? Because these are only the count of the labels that we found, that we got from the from its children. So for that, we're gonna check if the map has the label of the given node. If it doesn't have the label, then we set it to 0, and then we add a 1 to it, else we just return it. Now let us call our DFS function. You don't need to pass -1, because if you don't pass anything here, then automatically the value of the parent here becomes undefined. And if you just pass a -1, it's -1. So basically it doesn't matter if it's undefined or -1, because either way it's not the parent would still be not be its neighbor, right? So what do is now we return our final result. Now let's try to run our code and see if everything works fine. Okay, I made some mistake here. All right. Okay, so what I did not do is I created the map, I created the count, but I did not update my result array. I have only defined it and I just returned it, but I did not update it anywhere, right? So result of the node should be equals to the value of the label, the count of this label, right? And that's stored in this map. Now let's run our code. Cool, let's submit it. Did I submit it? Okay, let's submit it. Great, so it's been submitted, as you could see a few seconds ago, just right now. And then yeah, so talking about the time complexity, so we created this array in O of n time complexity. Also the ages, this for loop is also of since the ages array is of length n, so it also takes of n time complexity. And this is also of n because we are only looping over its child only once, right? We are going through its neighbor only once, because if we encounter the neighbor again, then we are not calling the DFS, right? So this is also of n, so basically 3 O of n. So since we discard the constant, so the time complexity is just big O of n, and the space complexity is O of n because we are using an adjacency matrix and also a result. So here also we discard the constant and then the value is just O of n. Hope it was helpful.